Hi everyone. The purpose of this video is to investigate a little bit about the cross product. The cross product is the second way that we can multiply two vectors. The first way being the dot product, which hopefully you've seen previous videos or you recall from class. The cross product is also known as the vector product, meaning that if you multiply two vectors, you're going to get a third vector. So the first definition right here tells us that u cross v is equal to a vector which is normal, or rather orthogonal, to u and v both in direction using the right-hand rule. So it's going to be perpendicular to both of the vectors you start with. This little n right here is supposed to be a unit vector which is normal to both. And then the magnitude of this vector is equal to magnitude u, magnitude v, and the sine of theta, which is the angle between the vectors. Okay, this first definition is very, very complicated to use if you are actually going to compute the cross product of two vectors, which is why we have the second right here. Now, this second definition is similar to a dot product, except we're getting a vector. We have three components. We have the u2v3 minus u3v2 component, comma, u3v1 minus u1v3, comma, and then u1v2 minus u2v1. Now, I don't remember this formula this way. I use a determinant to help me remember the formula itself. And I'm going to show you how that works on the example that we have down here below. Okay, so the way I would compute the cross product is as the following. Let's find u cross v. So the way I do that is I say that is the same thing as thinking I'm taking the determinant of a matrix with unit vectors I, j, k. Now in the second position I have to put u because it's u cross v. So u comes first, so I will put u first, 3 minus 2 and 1, and v comes second, so I will write in v in the second, or rather the third row, the way you look at it, it's the vector 2, 4, and then 3. Okay, so then that is equal to, and I think of it as I, times a product with a difference, minus j, and then plus k times, and then I fill in the values. So when I compute the I values, I'm going to use the 2 times minus 3, and then minus 1 times 4. So that will be 2 times minus 3 is minus 6, minus 1 times 4 is a minus 4. When I compute the j components, I'm going to use the 3 times 3, which is 9, minus 1 times 2, which is 2. And then finally, when I compute the k components, it's going to be 3 times 4 minus 2 times negative 2. 3 times 4 is 12, minus 2 times a negative 2 is a negative 4, so minus a negative is plus 4. So I get the vector minus 10i, 9 minus 2 is 7, but there's a minus out front right there, so minus 7j, and then plus 16k. If you want to go back to the component form, it would be minus 10, minus 7, and positive 16. And that is the cross product of those two vectors. Now keep in mind, it's supposed to be perpendicular to each of the first two vectors, and we have the perfect tool, the dot product, to check and make sure that that's true. If we wanted to check that u cross v dotted with u, well, that would be minus 10, minus 7, 16, dotted with our original vector u, which was 3, minus 2, and 1. Doing the dot product, we'd have minus 10 times 3 is minus 30, minus 7 times minus 2 is plus 14, and 16 times positive 1 is plus 16. And sure enough, like magic, it's equal to 0, which means that u cross v is perpendicular to u. Similarly, if you checked with v, it would also be perpendicular. In the next video, we will look at some properties of the cross product in terms of areas and magnitudes and things like that. Thanks. Bye.